F5 Local Traffic Manager. We're getting to the big IP, the initial setup, but well, at least the concepts with it right now, and then we'll dive into the stuff about pulling it all together. So everything we need to do to get started out of the box, what are we going to look at? What are we going to do? What do you have to do to get started on this stuff? So, as we get started here, again, we're kind of going into this to look at our initial setup concepts. And this is going to be, well, obviously concentrating around our wonderful little box here that can actually have multiple personalities. Not that we mean it's really schizophrenic in our system, but the same devices are used for a number of different things. And in particular with that, and we may have, I guess kind of a good way to think about it, look for some micro nuggets on ways to back off and give the overview of a lot of this, but specifically we're going to be looking at our local traffic manager portion from an application deployment perspective. Okay. So these are all going to be for the application deployment controllers. So ADC is a nice little acronym that we kind of come up with on there for where we're putting them in to balance our applications on the network and the way that our users are going to access stuff. So in this particular nugget, we are going to talk about the different big IP systems. So we'll see that name for a lot of things. That's what they call the boxes. But we'll look at some of the different types in there, both physical and virtual. And then we'll get into the portion of what it is to set it up, because out of the box or the initial deployment, what kinds of things are going to be important and what do we need to worry about. So once we get the physical-ish, when I suppose with VM it's not really physical, but the device perspective out of the way, then we'll get into the specifics that are more generalized to each one. So we'll talk about the management interfaces, and of course the important part, the software licenses. So what specific personality are we going to put on the box, and how are we going to balance that information in there? And then we get this really cool word. Okay, so we get kind of an expansion of our English vocabulary in here. I mean, how many companies actually officially use the word dossier in terms of describing what the type of device is or the deployment of a device is? You gotta love the guys at F5. I absolutely love it. So we will talk about the dossier information and how that's important to the personality of the box, as well as how we're going to provision them in the network then. Okay, so that'll cover our basic setup, and there's a number of ways to do it in there. We will talk about it from both a physical box and a virtual box, and in the different configuration nuggets we'll show specifically how to do that as well. And then how to archive some of our information. Okay, well, there's a lot of different things in setting up a system, but these things right here, all of the options that we have right here, really give us our starting point where we can then go back and do the specific provisioning for what's going to be important for my network. So how I'm going to set the servers up, how my users are going to access stuff, how the traffic flow is going to actually work in there. So that's really kind of the secondary piece to it, but in order to get all that, all of these things actually have to be working perfectly fine. So that's going to be where we're going to get started in here. So let's go ahead and start talking about the different systems involved and the different things, different devices anyway, that we have at our disposal, all part of our LTM or local traffic manager options. So when we get into the hardware and stuff, there are, well, really a lot of different things to talk about in there. Obviously, the physical versus the virtual is going to be kind of a big deal. And really, once we start looking at it, we have to keep in mind that our physical offers us, well, hardware. So it's going to be different pieces and different things that we have involved in doing that. So keep in mind, from a physical standpoint, we have chips that we have built in for our SSL acceleration. And hardware-based compression as well. So lots of things that we can do in there. Now, there's other pieces, I guess, that we have, I guess some fancy things. So we'll call a OneConnect, and what do they have? They have an EPVA. So I'll just put the acronym down here, A. Okay, that is Embedded Packet Velocity Acceleration. So basically things that are involved in the hardware side for not only balancing our sessions between multiple devices, okay, so we'll talk about the capacity issues here in just a little bit, but also to help protect against denial of service stuff. Okay, so a lot of the things that we do, we have the physical boxes, the hardware part, to allow us, extra contingencies, if you will. The VM side gives us a lot of flexibility in terms of deployment model, but not so much as this, because we're much more dependent on the actual hardware that we do deploy stuff on. So from a design perspective, we'll kind of keep that part in mind, but for right now, I don't want to get too into the weeds for it as far as what's good one way or the other. Okay, so that's about as much as I'm going to say. I would be aware of these differences as far as the physical aspect goes, but beyond the simple mention of them, that's probably about as far as I care to get into it. Now, there's going to be enough in terms of our physical boxes. Okay, so there's a huge variety of them, if you will, that we kind of get into and take a look at along the way. And again, I don't want to spend a whole lot of time in the weeds for it, but it is kind of important to know what some of the differences are. So my first grouping, let's see, 11050, 11,000, 0-VSSL, 0S, 5900, 7250, which is also an SSL1, and 7050S, and the 6900. So these are going to be my larger boxes, and what's important about those, basically, from a numbering standpoint, typically the bigger number is going to be the more powerful. I suppose that's an easy way to think about things in there. Anything above 6900 is going to automatically have dual power supply. Anything that's below 6900 has the option of a dual power supply. So, be thinking high availability here, because your entire design for your network, remember the big acronym was my ADC. So my application deployment controller, everything that we're doing is focusing on the efficiency of applications throughout a network. That's why F5 exists. That's why we do load balancing and everything else. So it stands to reason the high availability concepts come into the design, even though it is a point device. So it's not just a single point device, but you may have multiples of them. We'll get into clustering and things like that in later nuggets. But that's all part of our equation as we go. We'll step back and kind of break things down into simple concepts, but keep that in mind, though, on my higher end boxes in particular. Now, a couple pieces that I want to look at in here. Okay, so let's put connections, and I have both max and per second, and then I have throughput. Okay, so my total volume, or my total amount of traffic going through there. And that's really what's going to be setting apart these different boxes in here. So when we start looking at things like the 11,050 as an example, can handle 24 million connections, but it can handle a maximum of 2.5 million per second. Whereas the 11,000, 24 million simultaneous connections, also at 2.5 million. Per second on there. The difference is going to get into in the throughput. So 42 gig total throughput on the 11,050, whereas only 30 gig on the 11,000. So when we start looking at our applications, there really is a number of different things that we have. So depending on if it's a call it a high-intensity application in terms of the amount of data that it puts through here, then throughput is going to be one of my most important features. If I look at stuff where it's very small transactions that are happening, but a whole lot of them, then I'm getting into both my total connections and my number per second as far as being the more important part. And we'll see some differences as we get down to the different boxes where it may seem low over here and high over here, or low over here and high over here. Like I said, it is a balancing act, not to be too punny because we're talking about load balancing, but it is a very specific specific design criteria that we look at for picking which of the physical boxes would go into a particular deployment. And you may have one customer that has a whole variety of these, or you may have multiple customers with exactly the same one. You'll have all sorts of different things, but we need to be aware of these three important pieces in terms of what we're bringing to the table for how these are going to work in each of the deployments there. So, and again, this is not going to be a memorization. There are data sheets to go ahead and take a look at these, but I wanted to kind of show the comparison in there. So the 10,250 is an example. Let's see, 36 million here, 36 million, but I have some variance as far as 2 million per second versus only 1 million per second in those two boxes, and the total throughput's about the same. So this, again, being kind of a key thing. Why would we pick one versus the other? Well, your difference is right here. It's how many transactions per second are going to be important for that particular deployment, and that'll kind of get me down to it. So let me go ahead and write these in. We'll kind of speed this up as far as the typing out goes. Okay, so just kind of reviewing things on here again, same ideas, 12 million total, but a difference in how many per second, really a difference in total throughput as well. In the 7000 series, same throughput, or same total throughput over here, same total throughput in terms of connections, but a variety in terms of the maximum per second. 6900 was an older box, by the way, so that's kind of why the bigger jump in there. But all of these have built-in dual power supply. Everything else that we're going to talk about has the option. So this is kind of what I'm going at right here for some of our hardware. So we can pause it, kind of take a look at it. Again, I wouldn't memorize the table. I guess I'd key in on some of the older ones in terms of availability. So let's see, what are the more important ones right here. The 11,000 has been around for a while. The 8900, the 6900. I think I'd probably look at those as my three most important ones if I had to, roughly memorize anything for an exam, just because they've been around longer. So, but that gives you an idea on that side. Now, let's go ahead and kind of do the same thing for my ones that have the single power supply but dual optionals. So we'll put these as my single power supply. Keep in mind, all of them have an option to expand to a second, so we can still be highly available with them. So as we can see kind of in the disparity part right here, that this is getting a whole lot different for where we're at. I mean, obviously the decrease in number of total connections and whatnot, but we see more of the spread in here compared to the last set of how many connections per second, and also the total throughput obviously goes down. So it is that, again, not to use the term too much, but balancing act in design over what device we're going to put where. The important ones that I list on this page, from an examination standpoint, 3900, 3600, and 1600. Again, my three older boxes. So a total of 6 of them that I'd really pay attention to the information on. Again, single power supply by default, dual is an option to it. But that really kind of goes through, I guess, the devices as far as what I would be concerned about or what I'd be thinking about in there, and really how to set them up. You're going to see everything from a CPU standpoint, from dual cores to quad cores to hex cores. Some of them have more than one of them in the boxes. You know, there's data sheets for that. Don't stress yourself out on memorizing that kind of stuff in there, because, you know, in the end, you just don't really care that much. There are other things to kind of keep in mind, or other pieces involved with it, if you will. Okay, so different sets of information that we have along with it. So we have a whole, those were all the big IP systems, by the way. We also have a whole set called Viprion, and that is really blade based. So those are my blade servers. There's a whole number of those. You know, just anything with Viprion is going to be a blade server. So know that from an exam standpoint. And of course, there's also the VM version. Now, cool thing about the VM version, we can work on, and we'll just call it virtual machine, not VMware specifically. VMware is one of the ones that we work on. In terms of my hypervisors. Okay, so there's a whole number of those in there. So I've got VMware, I've got Citrix, which is the Zen server. I've got Microsoft's hypervisor. I have AWS, so the Amazon Web Services, the EC2. I suppose I should put that there because they do have a couple different versions of things, but EC2 is the one that we have. And of course a straight Linux hypervisor. So those are the different hypervisors that the VM edition will work on. There's not really anything as far as a specific spec involved for total throughput, because obviously that's going to vary based on your specifics right here. You know, what kind of hardware is behind it, what kind of connections are behind it will drastically affect how the VM actually performs. The VM edition is designed for ease of deployment and bringing the things out there. Remember those hardware chips that we talked about? Obviously, VM is not going to offer any hardware acceleration, any hardware-based denial of service propagation, or anything along those lines. So it is simply for an ease of deployment that we get into it. But obviously some fairly cool things that we do get into for it. So all the interesting stuff. One other piece from a management standpoint that I want to bring out, and it really kind of brings us back to the physical side, there is a chipset called AOM. Okay, so the 8900 series and below all have this AOM chip. Stands for Always On Management. And really, as long as the thing is plugged in, you don't actually have to have the box powered on, but you have some management capabilities that are able to still be done. It's a chipset with a built-in micro Linux kernel. It has some really cool things, but basically they call it lights out management. Also allows for basic configuration via serial cable. So we'll say via serial. So you do have to have some physical proximity. This would either be you have to be there with the box, or you have to have an out-of-band terminal server. So that would be another way of handling your management remotely and out-of-band, so a different mechanism in case you get a power failure or something like that. So different things that we can do, different ways of managing the overall system in there. But that's the parts that I would be aware of from the hardware perspective. After that, it's getting into, well, what do we do? Pull out of the box. What do we have? You know, it's going to be something, either a 1U, 2U, 4U, could be bigger if we got a blade servers and stuff, but it'll be a box that we actually physically deploy, and once you get it out and plug it in, because power supplies and stuff, I'm pretty sure I don't have to explain those to you, because you do have stuff plugged in, right? Okay, like your laptop that you're watching this on right now, is it plugged in? Oh, it's tablet? Okay, cool. You're good. You're fine. Okay, but you get the idea. We still have certain basic concepts that we don't need to go over on here, but are fairly obvious. Plugging it in, having a network connection, those basic things are going to be part of it. But let's go through the different methods that we have of actually configuring these boxes now and seeing how we're going to get started. Because, you know, like I said, this is just the beginning part of, okay, what box do I need, or what am I going to deploy? Now that we actually order something and have something, or better yet, for our lab have it in, what is it that we're going to do? Okay. So the options that we're going to go through in here, and really what I have to play with, so what we'll be talking about most is the big IP 1600, so that's what I have in my lab physically, and then we also have the virtual machine edition that we'll be playing with on an ESXi server. Okay, so the VMware ESXi. So that'll be our primary concern for what you and I are going to talk about. But honestly, everything that we're going to do, we have the physical side, we have the virtual. Whether you're using it on any of these hypervisors or whether you're using any of the other physical boxes, conceptually, we're going to be exactly the same. So good news is we have specific representations of both sides, and we're going to be able to play with both of them. So let's go over those concepts for what we're going to do once we get it out of the box and check off how we're going to get things set up and what our next steps happen to be in order to get us where we can actually play with it. Because I know you and I are both the same way here. We're wanting to get in, make it happen, get in there, understand the details that are going in to actually make this function in the network, because that's where the cool stuff happens anyway. So let's get to that. Alright, so let's kind of play around a little bit and take a look at a physical box right here. And this will be the 1600 series that I've pulled out anyway. So as you can see from, well, forget about the wires. Okay, so we kind of zoom in here on the LCD panel, and this will be impressive and helpful for us in terms of our setup. And you get your status buttons and whatnot, which again, nice things to know about. Only got one power supply. 2 SFP ports there, 4 copper ports, 10100, 1000, and then we have our serial port and our failover for doing high availability stuff, and then over on the left is our actual management Ethernet, so separate from the other 4 are data plane Ethernet, and a USB port there. So like, our normal networking gear, routers and switches and stuff like that, we really have different planes of information to think about. So a control plane and a data plane. Okay? And our first part about our getting started, or our initial setup here, happens to do with that control plane portion. So how are we going to control the F5 device here? And so we've got to set stuff up. And we really have multiple methods of doing that, all on the physical product. And so they happen to do with things like our LCD panel, or get our little pen here. Okay, so our LCD panel down here, got that information, as well as our management stuff up here. We have both the console port, so a serial-based connection right here, as well as an Ethernet-based management connection. So really 3 different ways that we have in order to really set stuff up and get our basic portions moving. Now, that being said, so our IP address portion, our IP controller portion right here, does have defaults. Okay, so we have information already set up for us. So even out of the box, we're set up with a 192.168.1.245/24 address. Okay, so we can get here via the HTTPS management port even without doing anything else. But by the same token, I can use the LCD panel to set an IP address or change an IP address in case we're acquiring something different. I can use the console port to do the same thing. So we got a lot of different ways that we have to be able to go in. Now, a couple different things though. When I go in via my serial port, I will go in with the root access. Password, of course, is default. If I'm going in via web, then that's going to be a little bit different on there. I am admin. So different things that we have are different accounts that are set up. Now, of course, we can go in, once we get in there via the web browser, we can go in and set up additional users and all the other fun stuff, and we will get to that. So we'll teach you how to do that portion. But out of the box, out of the box, we have some default setups that we can go ahead and play with on there and get us exactly where we need to be. Alright, so really the next most important thing after we gain access into the system is going to be licenses. So licenses, everything that we're going to look at here is going to define what it is that system happens to look like and how it happens to behave. Okay, so basically 1, establish access. So access the box, do all that, fun stuff in there. And 2, we're going to get the registration key. Okay, now the registration key itself is either going to be on the system already or would be entered based on information that you receive to it. It's going to be 27 characters. So it's going to be kind of long. You might want to, type it nicely and all that jazz. And once that happens, then magically we're going to get the dossier. Or the dossier if you're from the South. Okay, not to be confused with square dancing or anything else. That would be a do-si-do. So, but other things that we do in here. The dossier is going to give us all the information, the file, if you will, the background information. The when you watch spy movies and things like that, everybody says that the FBI has a dossier on everybody. That's your file. That's all those things that you've done that you haven't told anybody about. Well, somebody knows it, and guess what? Your ADCs are the same way. They have a history, they have a background. Well, they got capabilities anyway, and that dossier will tell them what that's going to be. And when we do that, once we get our registration key and everything else, we send that to the license server. So that goes out and connects to F5, gets the information in there, and of course gets a response back. So we have something called the bigip.license. And that's probably the most important file that we're going to have. It's in the config directory, but it'll be sent back down to us and put onto the system in there. And then once we do that, then we move on to provisioning. Okay, so we provision the server. We do have to reboot it also when we're all done, so I'll kind of say, and reboot to make everything alive. But this is going to set up exactly what it is that we have, how it is that we're going to be, working, I suppose, is a good reason for it. And we'll show this to you in the config portion, so we'll get a good sense of exactly what's going to be happening in there in terms of where we go for provisioning. Okay, because provisioning is going to be really the next most important thing, because out of all those things that we're licensed for, so all the different features that we have to figure out how the server is going to behave. Because we may be licensed for more features that we intend for that particular box to use. I know that sounds silly, but they come as bundles and all the other fun things that go with it. But I don't want to overuse the word balance throughout this course, but we balance all of the features that we're going to be using on the box and provision it for memory usage, disk usage, CPU usage, and stuff like that. Okay, so we'll get into that with the next section of our configuration part when we see how all of these pieces come together. But that is our initial setup. Okay. The archives, of course, like I said, we do want to pay attention to that. We'll show you how to do it. It's all off the web menu. But everything in our config directory is going to be the important stuff. Okay, that's going to tell us not only configuration for the box, but also things like my bigip license file. That's all the stuff that we definitely want to keep, or definitely want to keep track of. Now, when we do the archives, we configure things or send things out to, we'll call this asterisk because we got to name it, a UCS file. So those UCS files are what our backups are going to be, and we can restore from it and do all the other fun things. But that's going to be all of the pieces that we kind of put in place there. So we'll really kind of keep the same criteria that we go through in terms of the configuration, but actually see it happen. Okay, so our initial start, I hope we get everybody excited about what F5 is. Okay, so our F5 equipment. Most importantly, those ADCs. Okay, so the application deployment controllers, application distribution controllers, I guess depends on which acronym you happen to be looking at, but all the things are going to be surrounding the performance of our application in here. So we go through how we do initial setup, how we do the configuration, either through the LCD, the serial port, or the Ethernet, as far as setting up our IP address and all the other fun things. Okay, we talked about our defaults for getting in there. We're going to show you how all that works next, kind of go through that portion, but for right now, get the basics of what we need. And of course, the next big thing is going to be the license, which moves us into that wonderful world of, what's that fancy word? Yes, the dossier. Right, and that'll tell us exactly how the system is going to be behaving, which of course, again, leads us into provisioning. So that's our initial setup to get us ready to be able to put one of these devices into our network and start moving things around and helping out our applications. I hope this has been informative for you, and I'd like to thank you for viewing.